Today we're going to discuss threat emulation in practice. And what do we mean by that is we're going to talk about one of the most prominent frameworks in the field of threat emulation, which is Atomic Red Team. So Atomic Red Team is a library of tests mapped to the MITRE framework. So what does that mean? Remember guys, in the last video we talked about threat emulation and we said that one of the main objectives of threat emulation is to mimic the attacker's behavior. So in the case of MITRE, remember that MITRE is composed of techniques and tactics, or tactics and techniques. Let's say you want to implement these techniques. What you're going to do, you're going to go and use Atomic Red Team. Atomic Red Team, I'm going to call it, is the practical implementation of the MITRE framework. You will get to use, or you will get to execute every single technique under MITRE. Okay, right. Now let's talk about the main components of Atomic Red Team. So Atomic Red Team tool or framework is composed of atomics and tests. Okay. Now the thing is, atomics are the ones that are mapped to the MITRE framework. Okay. So basically, an example of an atomic is T, say 1003. Now remember, T1003 is the name of a tactic in MITRE framework. At the same time, the Atomic Red Team uses the name of the technique in MITRE ATT&CK, and under the technique here, you will see the same name here in atomics. So this is called an atomic. And under the atomic, we have the tests. So the tests are composed mainly of, first, a markdown file and a YAML file. Okay. Now, what's the purpose of each one of them? The markdown file is information about the test. Remember that the test is the practical implementation of the atomic. Let's say an atomic that has the name of T1003, which is a MITRE technique. And let's say this technique, it's such an assumption, it might not be true. I'm just saying it for brevity and for speed. So let's say this technique or tactic, let's say this tactic is described as OS cred or credential dumping. Attacker uses this tactic to dump OS credentials. Okay. Now that is the description of this technique or this tactic. I was confused with them. So that's the tactic. Okay. Now under the tactic, in order to execute this tactic or try it in an environment which you want to test, you're going to execute the tests under the atomic. Okay. The tests are composed of one markdown file which contains information about the test, all the information you need, and a YAML file. Now the purpose of the YAML file is the configurations that are needed if you want to execute the test using the tools. Now what are the tools? Here we come to the how to use atomics section. Now how we're going to use all these atomics that are mapped to the MITRE ATT&CK. So basically there is a tool called invoke Atomic Red Team. This is a PowerShell module that we're going to invoke, and you will specify invoke atomic test to run the emulation. Okay. While running the emulation here using the invoke atomic text, you're going to specify the it's going to use the configuration file written in YAML. That's the objective of the YAML file. It is used by the test to run it smoothly against your target. Okay. Now, in the practical scenario, we're going to dissect the YAML file, understand its components, and we're going to run a couple of tests to simulate or to put that in practice. Remember, all the credit goes to the TryHackMe room named Atomic Red Team. This room is part of threat emulation, which is also part of SOC level 2 track. Okay, so we're interested in task number 3 for now. Open up the machine. Okay. So it is under cd c tools. Okay, and here we have the Atomic Red Team. Oh, invoke Atomic Red Team. And under, let's see here. I guess this is the wrong directory. Let's go back. CD Atomic Red Team. And they're all stored under atomics. See, these are called the atomics. As you can see, they are named after the tactic name. Now, if you take an example, let's navigate to T1647. Here we can see two files we talked about earlier, the markup file and the configuration file. Now, we will leave the markup file. I'm going to leave the markup file for you. It contains just, it's an informative file, information about the test. Now, here we have the configuration file. Okay, it's the configuration file, again, represents the needed configuration to be run by the tool. So let's take a look at the configuration file here. We're going to use type. Okay, so the first component is the attack technique, and we said that the attack technique represents the MITRE tactic. Okay, the display name. Now, display name is self-explanatory. It is the technique name, similar to how it is presented in MITRE. plist file modification. That's the name of the test. Now, atomic tests. Remember, guys, that don't confuse the naming. This is called an atomic. And these are the files needed to run the atomic. Now, we mentioned that every atomic consists of multiple tests, may contain one test or multiple tests. Go back. Here we have the atomic tests. Now, this lists the atomic tests that will be run against the environment or against the target if you choose to run this atomic as part of a threat emulation campaign. Now, after the atomic tests, we can see, guys, here the list of the tests. So it looks like we have only one test. Okay. First, we have the name of the test, plist modification. And then we have auto-generated descriptive identifier of the test. This is a unique identifier for every single test. And then we have the description. This is a longer form of what the test does. Modify Mac OS plist file in one of two directories. Remember, these are actual attack tactics and techniques. When you execute them against an environment or against a target, you're actually attacking or simulating an attack against the environment. Just remember this. These are not configuration management items or not things to install a package or something. Remember that this is threat emulation. You are emulating the attacker's behavior. Okay, next, we have the supported platforms. The supported platforms item here lists all of the operating systems against which the test can be run. In our case here, we have only Mac OS. And then we have the executor. The executor is the actual binary or the actual tool that the test will execute. So we have here the steps that will be taken to execute this test. Modify a plist under library preferences or another directory under library preferences. Subsequently, follow the steps for adding and running via. This was a very brief one. We might have to take a look at another one which might contain more than one test. Let's take a look at this. Okay, so this atomic has more than one test. See, you have this one, and we have another one, let's take a look here. So this one discovers system language by using a registry query. And take a look here, the executor uses a command run by CMD. The other test executes this command. So that's a brief breakdown of the configuration file of the test. Why this is important? Because in a threat emulation campaign, you will want to know what every test does before executing it against the target. Because upon executing a test, you will definitely modify the target system environment. So it's very critical to understand what every test does, and later on you will also want to perform a cleanup. We're going to talk about this in a while. Okay, now let's talk about the tool here, which is Invoke Atomic Red Team. Using this tool, you will be able to execute threat emulation campaigns. Specifically, you will be able to execute all of these tests against the target. Okay, now on the left or on the right, we have the needed information to get started. Namely, we have the installation steps. We're not going to cover these in detail because they are very clear from here. And how to import the module and list atomic tests. By the way, you can also browse the atomics using this page. This is the official page of the Atomic Red Team, developed by, of course, Red Canary. Right, now let's get started. Okay, now the first thing we will want to do is to specify a PowerShell policy to allow the execution of scripts. This can be done using this command, PowerShell execution policy bypass. It's very important to execute this command if you want to execute any PowerShell script that needs privilege, or if you have the execution policy set to disabled, you will want to bypass. Okay, the next thing you want to do is to follow the steps here after downloading or cloning the repository. The first step is to import the module. So we're going to import the module. Look here, the import module command will need you to reference the directory where you downloaded the Atomic Red Team, and you will want to specify the name of the tool, and then dash force. This will import the module into PowerShell. Alright, now the next step is to specify the directory of the atomics, the tests we talked about. Now, the atomics, they can either be downloaded and stored under the same directory where you downloaded Atomic Red Team, or as in the case of this room, they have stored the atomics under a different directory. That's why if you're doing this room, or if you're doing this as part of this machine, you're gonna need to execute this command. Oh, not this one. Let's see here. There is one command that needs to be executed where you will import or specify the path of the atomics. Okay, this is it. So here we define a default parameter. The default parameter includes the path of the atomics. So as you can see here, guys, the atomics are stored under tools. However, the directory or the framework itself is stored under different directory. Atomics are stored under Atomic Red Team, while the script itself is stored under different directory, Invoke Atomic Red Team. That's why we needed to use this command to specify the path. Otherwise, you'll get an error or multiple errors while working with this tool. If you have Atomic Red Team installed in your environment where the atomics are stored under the same directory, you're not gonna need to execute this command. So let's do that. Execute. And now to start, we're gonna type help invoke atomic test. If this works, Now this works. It means that the model has been imported successfully. All right, now how to start the threat emulation. Remember guys that the very first thing before we start is to understand what every tactic, or understanding the atomic under which the tests will be executed. We need to know what it does. So the first thing we're going to do here, we're going to say invoke, okay, atomic test, and to pick up a specific testing technique that we want to execute or try. Remember that we use this one as an example. So let's take this one as an example and start with it. Remember that we don't want to start this. We want first to get information. So we're going to say specify the name 1614001 and use show details brief. There is a typo here. Okay, as you can see, we get a list of the tests. So in total, we have 2 tests under this atomic. The first one, discover system language by registry query, and other one is discover system language with CHISP. Okay, now if you want more details, and that's what you need to do, you need more details. You need the executors, like how the test shown here or named after this will execute or will accomplish its purpose. You will want to know what it does, what are the commands that it executes. For that, I'm going to use show details only without a brief. So let's take a look here. Here we can see, guys, the every test, the identifier, the name of the test, the description, and the attack commands. The executor here is command prompt, meaning it is executed through command prompt. And here is the exact command. It's like you are taking this command manually and execute by yourself. You can do that, by the way, without using the Atomic Red Team. You can do them individually. Like you can invoke show details, take a look at the commands, and you can execute them by yourself if that's what you want, if you want more control. Now, the other test uses this command. So make sure to invoke these 2 commands first to be familiar with the atomic and the tests. Okay, the next step we want to do is to find out if we need any prerequisites to run the tests under the atomic. Now, with this example here, you can see that the executors or the commands executed by the tests use built-in tools in Windows operating system. So it is definitely not needed to install any prerequisites, but in some other tactics, there will be tools that are not built in or not, come with Windows operating system, which means you will need to install them. That's why the next step you will want to do is to check the prerequisites. Let's take another example. Let's take a look at this one. So T571. Now this one has only one executor or one command. Let's check the prerequisites. We check the prerequisites after specifying the atomic name and specifying dash check prerequisites. Let's take a look here. So check prerequisites for this test. And as you can see, it's telling you that prerequisites are met. There is no further action to do here from your side to install a tool or to install a dependency. Now, sometimes you will get prerequisites not met. In this case, and if you don't know how to install the prerequisites, you will want the tool to do that for you. So to do that, you can just execute get prerequisites. So get prerequisite. I'm not going to execute this because for this atomic, we have the prerequisites met. But that is the argument you can use to install the prerequisites if you get prerequisites not met. Now, after making sure that we have all the prerequisites, all the tools, and we are equipped with the knowledge or the required knowledge to know what every test does, we can proceed and execute the tests. Now, how to execute the tests? There are multiple methods to execute a single test or multiple tests or all the tests. Remember that there might be one or more than one test after every or in every atomic. So the execution takes into consideration the number of tests you want to execute. For example, you can say invoke atomic test, specify the atomic name, and then we can execute all the tests or only a single test. In the case of T1571, we have only one test. But in case there are more than one test, you will want to specify which one you want to execute. For example, we can specify them using the numbers dash test numbers. Here we specify the test number. As you can see, the test number is noted by atomic test number. So you can say 1. Okay. Now, if there is another test, you can say specify 2. Okay. If you want to execute all the tests, you can just say all. Okay. If you want to execute maybe half of the tests or more than one test, you can specify their numbers 1, 2, 3, 4. Okay. The other way to execute the test is by using the names, and I don't like it, but it does exist despite me not liking it. So test names, and we can specify the test name. See here, the test name is indicated by the field atomic test name. We can copy this. Remember to use double quotes. Look, I copied the wrong one. So we can say test names. That's how it works. And there are other methods as well, such as using the unique identifier. This one. Alright, now let's solve a practical scenario. So the practical scenario here is task 2. And we're required to answer these questions. So how many atomic tests are under atomic T that are supported on Windows host? Let's clear the clutter. And now we'll get started. We want to find out how many tests under this atomic. So we can copy the atomic name and then invoke, or just use this to autocomplete. Show details brief, we'll do the work, we'll do the job, and then specify the name of the atomic. So here we have around 4, right? Despite the fact that they are numbered like 1, 2, 3, and 6. Looks like there are 2 tests skipped here, but the fact is that there are only 4. What is the atomic name of the second test under atomic T1218? So here we want to retrieve details about the tests. Okay, so we're gonna have to invoke another command. Gonna cancel the brief and show details, and don't forget the atomic name. So this atomic is rich of tests. Let's scroll up. So we want to find out the second test. Okay, scrolling up until we see 2. So atomic test number 2, and we want to find out the name of the test. The name of the test is indicated by atomic test name, and that's the name. How many prerequisites are not met for T1003? So you're gonna have to go back here and use check prerequisites. Remove this thing, question mark. Okay, so see here, still running. Okay, it's finished. Now for this test, we have one prerequisite that is not met, and this tool doesn't exist on the system. We have another one. So it looks like we have 1, 2, 3, 4. So by counting the prerequisites not met, you will get the total number of tests which need prerequisites. Now, remember that if you get this, what we're gonna do, you're gonna install these prerequisites by using get prerequisites as we specified earlier. What is the parameter used to execute a specific atomic test via the unique identifier? It is test GUIDs. And what's the name of the scheduled task created after executing the second test of atomic 10.53.005? Okay, looks like we're gonna need to execute this one. Okay, let's follow the methodology here. First, we're gonna specify the name of the atomic, and we're gonna retrieve the brief details, show details, brief. So we have around 9 tests. We're interested in the second one, scheduled task local, right? What is the name of the scheduled task created after executing the second test? Remember that you can answer the question without even executing the test. How? You're gonna just use show details about the tests. So here we are interested in the second test. We're going to scroll up until we find the second test. These are the attack commands. And here we can see that it creates the tasks. But yes, look here. This is the task name. So this can be answered without even running this. What is the registry key modified after executing the second test of atomic 1547? Now, for the case of this one, we're going to execute this just to show you guys how it works. So we're going to specify the atomic name, and we're interested in executing the second one. So we're going to use test number, test numbers 2. It looks like it is modifying a registry key. The registry key name is run once, but the answer is different. It is run once still, but you'll have to include the full path. Now, after you will see in a while that the output doesn't show the full path of the executed registry key here. So to find the answer, what you're going to have to do, you're going to do the same thing we did for the previous one. You're going to retrieve the full details and find the registry key path. At the very end, we're going to conclude this room by solving task 7. Case study emulating APT37, where we get the chance to emulate an advanced persistent group named APT37. So, going to practically demonstrate the process of threat emulation using this group. The first step to do is to navigate to the MITRE ATT&CK. So, going to MITRE, we're gonna have to find out what are the tactics and techniques used by this group. I'm gonna search for APT37. And reading the description says that it is a North Korean state-sponsored cyber espionage group that has been active since 2012. The group has targeted victims primarily in South Korea, but also in Japan. And we can see the other names, the techniques, and we also see the list of software tools. Okay, let's open the navigator to have a graph view of the tactics and techniques. Okay, on the other hand, we have the machine up and running. We're gonna use the Atomic Red Team. So first, let's make the font bigger here. Properties, font. Okay. Let's get things ready first by setting the required options, bypassing the execution policy in PowerShell, and importing the Atomic Red Team module using this command, which we explained in a while ago. And we're going to define the path to the atomics using this command, help invoke atomic test. Okay, now the tool is working. Let's go back to the APT, and now we have the navigator. All right, now the first step is to make sure that all of the techniques we see here are found in the atomics. So we're gonna turn to the machine here and use ls, define the path where the atomics are stored. This is the path. Okay, and then we're gonna use where object name dash match. Okay, so here let's take an example. If you want to find out if a specific technique exists, we're gonna have to copy the technique name and use it here. So it looks like all of the tests are found for this technique. Okay, and you can repeat the same for all of the other techniques. Let's scroll down and see what are the requirements to be met here. Using the ATT&CK navigator, how many techniques are attributed to APT37? So we go to the navigator and we only focus on the highlighted techniques. If you count them, okay, you're gonna find that the answer is 29. Okay, using the mapping provided by ATT&CK navigator, what is the phishing technique used by the threat group? I'm gonna go back to the navigator and locate the phishing. So here, what we're looking for the technique that can be used as or under the initial access tactic, because phishing is used as a vehicle to compromise credentials and get access to or compromise machines. So it's under the initial access. We see there's only one phishing technique named spear phishing attachment. And also you can find it here. If you look for spear phishing, you can see under phishing there is spear phishing attachment. How many techniques attributed to APT37 have an existing atomic file? To answer this question, I'm going to go back to the same command here where we use the cmdelete where object. And instead of using only one technique at this time, we're going to have to compare all of the techniques under this group. So we're going to have to kind of list all of them here. Maybe you can start like this. So the first one, going to first use double quotes and close everything in double quotes. Okay, and then use pipe and copy the other ones. Let's run this sample here. And now we can see that we have the available tests for these techniques, namely 1071, and we have 1123, and we have 41548. Just continue doing the same for the rest of the techniques, and you will be able to get the final answer. Now the final answer here will be the number of techniques attributed to APT37 which have an existing atomic file. Now remember that this is an atomic file. Okay, all we have to do is to continue the rest in the same command, and you will find out and count them here. You will find that they are 21. Based on the results of question 3, which atomic has no tests supported on Windows? Now, what we're going to do, we're going to take every single one of them and use a for loop in PowerShell. For example, let's take this one and the other one, the other one is for okay. Let's stop here and then use a for loop for each of these items of that represent the atomic tests. For each object, we're gonna use echo, and we're gonna invoke. Okay, we're gonna invoke Atomic Red Team, the show details brief argument, to be able to automate this. You know, that method. Let's say we echo enumeration or enumerating, and then we're going to use a $, underscore, and use a semicolon. Then we're going to invoke atomic test and use the argument show details brief. Let's make sure everything is correct. Okay, let's see here. As you can see, guys, now we get to see the details, brief details about every single, test. Using this method, we will be able to find out which one has no supported Windows tests. Alternatively, you can use the show details. If you want more details about every single one of them, you can just do this. We'll find the answer to be this one. Okay, next question. What is the description of the prerequisite needed for atomic test 1055-1? Alright, let's clear this clutter and use invoke. Let's invoke the command. Okay, no problem. Invoke atomic test T 1055-1 -check What is the description? The description says that the 64-bit version of the Microsoft Office must be installed. That's the description of the prerequisite. How many atomic tests have met the prerequisites of 1082? Okay, you're gonna do the same. This is 1083 and this is 1082. Check prerequisites. Looks like all of the atomic tests here met the prerequisites, except one, which is SkyArc. If you count them, you will see that there are 15 tests. Don't count the duplicate lines. You'll see they have 15 atomic tests met the prerequisites of atomic 1082. Now the next question, what are the 3 event IDs logged based on the execution of atomic test 1547-001-3? Provide the IDs in an ascending order. So we're gonna have first to execute this atomic test. Let's copy the ID and invoke like that. Here we invoke all of the tests under this atomic. The next thing we want to do is take a look at the event viewer. Once the event viewer is open, we're gonna have to use the sys monitor. Microsoft, Windows, and here we locate sys monitor. Now if you take a look at the first one, it is process create event, and the following two are the same. Then we have registry value set. Then we have file created. If you follow through the list of events, we can see they are all similar: process create, file create, and registry value. You have a couple of DNS queries, but we are not interested in these pertinent to the current scenario. Let's examine the first one. See here, process create. The process that was created is MMC, so this is not the event we want. Take a look at the second one. It is the service host. The third one, it is Windows Smart Screen. And Windows Smart Screen is an executable that is spawned whenever you want to execute a partial script or an unknown executable. So this is probably an event that was logged because a partial script was being executed. Next we have registry value. And see here, the registry value is being set by PowerShell process. And that's the target registry value. It is the run once, and the value indicates a PowerShell script. It is a discovery file under the Red Canary Atomic Red Team. And the next one is file created. Take a look at the file. This is a script created under the temp directory. Next one we have another process create, and this time it is the PowerShell process, and that's the command line. So it looks like the process create, the registry value, and the file created are three events are tied to the atomic test we have executed. So the event IDs are 1, 11, and 13. So 1, 13. What command is executed with default input value by atomic test 1529-1? Do not run without the show details parameter. So here we're gonna have to first take a look at the details of this atomic test using the show details parameter. So we're gonna go back to the PowerShell here, clear, and modify this to point to the new test, and then use dash show details. So, we have a V here. Okay, the question is, what command is executed? Taking a look at the test, we can see that under attack commands, the executor is command prompt, and the exact command that was executed is this. Now with arguments, with input arguments, it's going to be this, right? So it is shutting down the computer. So that's the command without input arguments. Do not attempt to execute this. As you can see, you can answer the question without the need to execute the test, okay? Just use or find the answer using the dash show details argument. Next, what is the value of the target file name? What is the value of the target file name attribute inside the file creation log? Event ID 11 generated by atomic test T1106. Okay, so here's the thing. Now it's going to be very hard to sift through all of these events, given that we have been running all of these tests. That's why it's always recommended to do a cleanup. So a cleanup can be performed by using an argument named -cleanup. Why cleanup is important? Because we want to clean all of the artifacts and maybe the changes or modifications that the test have actually incurred on the machine. So basically, to do that, we're gonna have to use the same command here. So remember that we executed this one, right? To do a cleanup, all we have to do is to invoke the same command as we are intending to execute the test, but this time we use -cleanup. Okay, now we're gonna have to exit this, okay, and run the test for this. Remember to do a cleanup, okay, between every test you run. Oh, cool. So this one executes calculator. Okay, now open up event viewer, and we're gonna have to locate a file creation event log and take a look at the value under target file name. Application and logs, Microsoft, Windows, scrolling all the way down to sys monitor. Okay, let's now try to find this file creation log. Okay, now after cleaning up, we have around only 15 events generated by the previous test. We're going to take a look at the file create. There is only one event referencing file create event. Taking a look at the value under target file name, we see it is this one, and it is referencing an executable that points to the technique name. So I'm going to copy this. How many events are generated by executing the cleanup actions of Atomic 1105? Okay, good. Now, what we're gonna do here, we're gonna clear this log first. We don't want this to overlap with the previous logs, so clear. Okay. The next thing we're gonna do, we're gonna scroll down, remove this, clear, use this command, and use the cleanup argument, but changing the atomic name. So we did the cleanup here for this test. Next, we're gonna have to examine the logs or the events. Refresh. Okay. Total, we have 28 events generated because of this cleanup process. Answer with 28. And that was it, guys.